this next section is going to basically solidify our understanding of what the different numbers do in different configurations. And so you're probably like, f of x, what is f of x? You didn't tell me what it is. Who cares what it is? Now, in a minute, I'm going to just use some examples. And the examples I will use will be, well, I'll show you. They're going to be square root. So I'm going to go back to here, and we'll graph based on the square root function. Nevertheless, if I started here, I'm just going to be looking at my notes, and I know down here I had x squared. I know I'm using that kind of as a backdrop for other things, but the bigger ideas remain that if I have a number in the front, that determines a lot of things. It determines the vertical stretch and shrink. If it's negative, it's an x-axis reflection. It also I can look at the number inside. Maybe it's inside here, maybe it's inside a square root somewhere, but it's inside these parentheses, and there's an operation being done to it. And that operation is basically the thing that houses it inside, and I will do the opposite. Notice the minus, that's horizontal, and outside there's a vertical shift, okay? And then the other thing I have not yet written down here is that if I have a negative x, like on the inside, like I did here, it's a y-axis reflection, which we're going to go ahead and see that one right now. We'll go ahead and write that one down. So this is a y-axis reflection, right there. How do you know? Well, let's do it. I've defined f to be the square root. This is a good one to use because it really lacks symmetry in other ways. So when it's reflected, you can see what's going on. I'm just going to type f of negative x, and when I do, you see that y-axis reflection. It's a horizontal reflection across the y-axis. Okay, so let's go back to the original, the first one, and we're going to have 2f of x. So you can do this, by the way. You can type a function, define some function, and then you can start configuring or tinkering with the other, and we'll put a 2 in the front. What happens? Well, it looked like a vertical stretch to me. It looks like it got taller. So what coordinate was at 1, 1, now it's at 1, 2. I didn't click in the exact right spot, but it stretched by a scale of 2. I knew that because, well, there's a number in the front. So it is a vertical stretch with a scale factor of 2. So it's times 2. Well, this is also a vertical. Well, you can call it a stretch if you want to use the vocabulary of stretching. A stretch of 1/2 technically wouldn't be a stretch, would it? But it's a vertical vertical transformation for sure. I'm going to call it a vertical shrink. I'm going to spell it correctly. Shrink. And then I multiply by 1/2. Okay, this negative in the front, well, I know what to do. If I have an a value, what's a? A's not in this problem. I know, but a is the number in the front of whatever's going on here. So a is negative, it's less than 0. So if that happens, it's an x-axis reflection. And if you need to see it, and you may not, you put a negative and see what happened. It reflected over the x-axis. I didn't put that 1/2 in. See, it's half the size of the other. And you can really do that. So if these things aren't coming to you, you can graph it in Desmos and see what happens. This is on the inside of what's going on. So when I'm on the inside of whatever operation I'm doing, then I will disobey my sign and I'll have a horizontal shift. So I do know I have a horizontal shift. Horizontal shift. And it's not -2, it's +2. And if you need it proved to you, then I will very quickly. I don't want f of x, I want f of x -2. And it shifted it to the right 2. It was at 0, now it's at +2. The next problem is going to be left 2. Horizontal shift to the left 2. So, horizontal shift of the left 2. And then this +2 is not inside the parentheses. There's nothing really happening with it, this being operated on. So it's just outside the parentheses. Let's take that out, and we're going to put +2. And it shifts it up 2. And I knew that because vertical shifts are outside of the most of the activity of what's going on. So this is a vertical shift. Vertical shift. And that's +2. And then, oh my goodness, there's a lot of stuff going on here. So let's go one piece at a time. I'm not even going to graph it. I'm not. Here's what I notice. There's a negative in front of f. The negative in front. If it's negative, it's an x-axis reflection. Well, it's a negative 3. Who cares that it's negative 3? Let's do one thing at a time. X-axis, reflection. Okay? It is negative 3, and 3 is greater than 1. Now, I know it's negative, but the absolute value basically is our way of saying, let's just pretend like it's positive. So, if it's greater than 1, it's a vertical stretch. So we have a vertical stretch with a scale factor of 3. Inside the parentheses here, we have x plus 4. That tells me it's a horizontal move. Horizontal shift. And that horizontal shift, I will disobey when I'm inside. It's going to be minus 4. And then outside the parentheses, there's a vertical shift. And it's at also subtracting 5. So it's going to be going down 5. If you wanted to see it, you could. And you would see all of these things at play here. You would see, here we go, I'll make it very quick, negative 3. Said I wouldn't do it. But when I do, you'll see all these things happening. It's taller, upside down, slid to the left 4, slid down 5, translated. We saw it coming. We knew that was going to happen.